Welcome to this lecture number 22. We will continue today HVDC, that is high voltage DC transmission, and one of the major advantage of having HVDC is to enable the power people to have back to back connection. Now, what is this back to back connection? For the first time it was used in EL river scheme in Canada. It is Quebec hydro system, which is perhaps one of the best hydro systems in the world at Montreal. So, from this to New Brunswick, that was a back to back connection, and in India we have 400 kV 500 megawatt Singrauli to Vindhyachal. Now, when you talk of back to back, there is no meaning in talking about break even distance, because distance is almost 0. Now, you see look at the diagram which is shown in the green circle is the back to back connection, and it can be housed in the same building. You even do not have to go to next building. Now, this is, do not think that this is the only way we can use HVDC. In fact, bulk power transmission is another important application of HVDC. Now, why do you need bulk power transmission? There may be an area like northeast where there is a lot of hydropower generation available. However, there are not much industries, there are not many people there. So, we do not need power right there. So, then if you generate that power, it has to be taken to a place where it is required. Now, power is required in south, for example, a lot of industrialization is there. So, what we do, we have a 2000 kilometer line built in 2002, which will carry almost 2000 megawatt from all the way from north east to south up to Bangalore. And there Bangalore and Hyderabad and Madras, being the industrialized, highly industrialized places in south, they need power and they do not have a local power available. There is a water problem, everybody knows about Kaveri problem. So, there we need this bulk power transmission. The another advantage is, if fault is there in AC network, this will not trip the units at the power station, because asynchronous DC link insulates the power system from AC system. So, that is, it acts as a as something which will avoid fault to take place. Had it been AC link, the fault would have affected this as well. Again, voltage and frequency variations in neighboring AC systems have absolutely no effect whatsoever on this DC link. It is immune, and this is what is shown in this figure, AC1 and AC2, and this is the DC link. So, this DC link has no impact of anything wrong in AC1 or anything wrong in AC2. Retention of tie under most stringent conditions of the grids is possible only if the tie is HVDC, not HVAC. High power underground submarine distribution. Now, do not think that there is no underground underwater transmission system. We do have at some places power transmission being done underwater, submarine distribution system. DC may be cheaper there, 50 kilometer with power level of 1000 to 2000 megawatt. All of you must have heard of Bombay High, where we have the Indian Oil Company. So, you need power there as well. Now, for AC you need force cooling, because the higher heat is generated. There is a I squared X losses also, which not many people appreciate. By losses, everybody thinks normally I squared R losses, forgetting the X is a major component. Please remember, R by X ratio is very small. So, X is very high, roughly it is 10 times R for a normal system. If X becomes closer to R, it becomes abnormal system, it becomes ill conditioned system. So, we need better cooling, force cooling if it is a AC system, because the higher heat is generated, again due to dielectric losses, which are much more in extra high voltage AC than in DC. Now, stabilizing AC system by modulating DC power flow also. So, it has a stabilizing effect as well. So, these are the various advantages of having direct current high voltage HVDC system. Now, what are the different transmission modes? Monopolar line, as you can see in a figure, is just a line has one energized conductor, just one, with a return path through the earth. Earth is being used for return conductor. It may be noted that the earth has a much lower resistance to DC as compared to AC. Such a line is called monopolar. Bipolar two circuits means both the circuits are identical. One conductor at a positive potential with respect to ground and second conductor operating at negative potential of the same magnitude. For example, when we talk of plus minus 500 kV or 650 kV, what does that mean? It means 650 positive as well as 650 negative. So, this is bipolar. A bipolar can be operated as monopolar. Suppose you do not need both, so you can have as well one, and it can work as a monopolar line. Monopolar cannot act as a bipolar, but bipolar can always act as a monopolar. Also, coronal loss and radio interference are reduced in a direct current. A two conductor DC line is more reliable than a three conductor AC line. Why? More the components, chances of failure are more. Fewer the components, chances of failure are less. I hope you must have all studied reliability theory at any one stage of your life so far. So, you know that series system is less reliable, shunt system is more reliable. Similarly, more components, more chances of failure. If fault on one conductor, the other conductor can continue to operate with ground as return. That is monopolar operation, which is not possible in AC line. Of course, there is you can't have everything positive in life in anything. So, the problem is why so far HVDC has not been so widely used, because the cost of terminal equipment were much higher than that of AC. In AC, the terminal equipments are substation and transformer. In DC, these are converter stations. Now, with the progress in power electronics over last 3 decades, this cost, like computers, whenever you buy next time, it will be cheaper. So is the power electronics devices, IGBT, MOSFETs, all these things are lot cheaper than what they used to be a few years back. Please give attention on this diagram or a graph which I have plotted. This is the x axis is kilometers distance. The y axis, there are two quantities for DC and AC plotted. The quantity plotted is cost. As you can see, the terminal cost is higher for DC and lower for AC. We have just stated that fact a couple of minutes back. But the overall cost goes up after a point P, and AC becomes costlier than DC. So, this point is called break even distance. So, if at all you have a HVDC line, it has to be longer than OP. If it is shorter than OP, then there is no point in using DC, you have to use AC. And now this break even distance also keeps on varying depending on the the advantages or advances in technology. Normally OP is around 700 kilometer. So if it is more than 700 kilometer, it becomes advantageous, cheaper, better, more reliable to use HVDC option. With progress in PE, break-even distance is reducing every year, every day. Cable, this distance is just 50 kilometers. If it is underground or if it is even above on earth, underwater, whatever, wherever you use cable, the corresponding distance is 50 kilometers. What are the advantages of HVDC system? We have been talking about advantages only, but let's list them point wise. Economical for long distance, bulk power transmission by overhead lines. We have just concluded that when the distance is more than break even, it becomes economical. Greater power per conductor and simpler line construction. Ground return is possible. There is no charging current. There is no skin effect. Voltage regulation problem is less serious. Why less serious? There is nothing called IX. This drop is totally absent. Only IR drop is there. Steady state stability is no problem, absolutely. Easy reversibility and controllability of power flow through a DC link. Control is lot easier. Only you have to play with the two voltages. There is nothing called phase angle, nothing called root 3, no root 2 business, no errors. You are likely to get full marks in numerical, because normally you make errors in root 3, root 2, etc., etc. Yeah, yeah. Well, we are now currently talking about advantages. We will come to disadvantages little later. Let us talk positive things first. DC line asynchronous or flexible link, resynchronization is not at all required. Then in headache, AC is a headache easy to again resynchronize. It can interconnect two rigid systems operating at different frequencies. So it can even make enemies talk. That is what it means. So even France and England, if they are interconnected by DC line, whatever happens in those France and England is unaffected as far as the DC link is concerned. So two rigid systems operating at different frequencies can also be interconnected. That is the real beauty of a DC system. For a single DC line between two converter stations, circuit breakers not required, whereas circuit breaker is a big issue in AC. Because control of converter stations can be used to block current flow during faulted condition. The whole idea of circuit breaker is so that current does not pass. Well, that can be achieved merely by controlling the converters. Each conductor can be operated as an independent circuit. So, its independence is there, and in probability theory independent thing is very easy. If you assume independence of events, the mathematics becomes lot easier in probability theory. Smaller amount of right of way is required because only two conductors. So, if it is 20 meter for AC, for DC it is just half, just 10 meters. Imagine how much more space is available for use if you have HVDC rather than HVAC, and space is a great premium nowadays. There is no space. If you travel in Kerala, there is hardly a single foot available for doing anything. Either there is a water or there is some construction. Considerable insulation economy. The point number 11, the advantage number 11. peak voltage of the 400 kV AC line is √2 times 400, 564. Imagine how much extra insulation is required because of extra voltage. So AC line requires more insulation between the tower and the conductors, greater clearance above the earth. There is no technical limit to the distance over which power may be transmitted by lines or cables. Whereas AC, you must have remembered when I taught you tuned power lines, they are not practicable because 4000 kilometer. Whereas in DC, technically, practically you may not need. Why transmit power to, let us say, Sri Lanka from northeast, unless until they pay you money? Because charging current is totally absent and stability limit, there is no such thing.
So compensation also not required, only at the ends it is required.
That's right, there is no required.
The middle no compensation required.
It's not required at all.
Only for harmonics usually.
Yeah, that's right. Line losses are small. This point we are again and again hammering, again and again repeating, because it is so important. It is possible to bring more power into an AC system via DC link without raising the fault level and circuit breaker ratings. No reactive compensation, this is a wonderful point, of DC lines is required because it is not there. Corona loss, this we already said, and radio interference are lot lower, lesser than corresponding AC values. Well, you can have a hybrid system. HVAC line and HVDC link can be used in parallel as an AC-DC system, and that is why the whole power system modeling is revised.
Compensation has become such an important issue for AC system.
Of course, that is why the whole area of facts has come in. Otherwise, why do you need facts? 18. AC-DC system is better than AC-AC. This is the conclusion. DC cables can be worked at a higher voltage gradient. Low short circuit current is required in DC line. So these are, ladies and gentlemen, 20 advantages in HVDC system over HVAC system, which is not a joke. It is a tremendous advantage.
So what is last point you could not understand?
Short circuit current, you know, lower short circuit current is required, not a higher one. And if in AC, the corresponding the short circuit MVA, if you that is a fault issue. Okay. Disadvantages. Now you can't have all advantages in any system, whether it is a whatever point you may raise, there has to be some plus points, some negative points. Nothing is absolutely perfect. Now what are the disadvantages? The systems are costly, since the installation of complicated converters and DC switchgear is expensive. Even people are today working in R&D, DC transformer, DC circuit breakers. So these concepts are still being developed, and no perfect circuit breaker or perfect transformer has been developed, but the efforts are on, and they are certainly costlier. Now this is something which is a real disadvantage. Not only that the DC cannot carry any reactive power, the converters require considerable reactive power. So you have to not only supply the requirement locally, the total requirement, because you cannot transmit any reactive power, but you have to also supply to the converters, which also need a reactive power. So reactive power management is a real issue in HVDC. Harmonics are generated with required filters. Since more and more power electronics is involved in the circuitry, it is a harmonics problem.
So, but they counter each other, sir, point second and third. So generally the same thing can.
No, reactive power is a load requirement. Only thing you have to understand is in AC you can transmit a part of reactive power, whether you like it or not.
Here we cannot transmit.
Here 0. That is all. That is the only point you have to see in point number 2. Fourth, converters do not have overload capability. Lack of HVDC circuit breakers hampers multi-terminal or network operation. There is no DC device which can perform excellent switching. Why? No natural zero here, like AC we have. Here there is no natural zero. You have to have a forced excellent switching operations and ensure protection. Even protection there is a problem. Simultaneous control at all converters is difficult. It is not impossible, but it is not easy. There is nothing like DC transformer as such, which can change the voltage level in a simple way. Voltage transformation has to be provided on the AC sides of the system. You have to do it and then convert it. Yes, but then they are all extra. It's not as easy as transformer. It doesn't become that easy. Like when you say AC or coolers, you can use pankha, sir. And pankha is how long you will go on doing like this. So there is no cost there, but then seventh, the reactive power required by the load is to be supplied. Yeah, this was the point I was making again locally. The word locally has to be underlined twice, as no Q can be transmitted over a DC line. Still there is no solution to this. You have to only have a local control. Pollution affects DC more than AC. More frequent clearing of insulators is required. Is atmospheric pollution. Future trends. This HVDC is a latest topic and lot of research is going on. PhDs, MTech level, and even in institutions like Power Grid, NTPC, BHEL, ABB, all this CPRI, they are all doing a lot of R&D. I don't know whether you know, CPRI has a a test 1 kilometer long transmission line in the field where you can go and do a lot of experimentation. Considerable R&D is going on for better understanding of the performance of HVDC links to achieve more efficient and economic designs of the thyristor valves and related equipment to justify the use of alternative AC/DC system configurations. So, future belongs to AC/DC systems. Perhaps there may not be any purely AC system in future, maybe 10 years hence or 20 years hence. How things will change, it is very difficult to predict. Any day there can be breakthrough and things can change. So, there can be a quiet revolution, but it is in offing. When exactly it is going to happen, it is very difficult to predict. Like a communication, this cell modular, this what you call cell phones have done a good revolution. Future power system would include a transmission mix. This is what I said just now, mix of AC and DC. What percentage I can't say, depends on need, depends on place, depends on money and so many factors. Future controllers would be more and more computer based. That is very obvious. I mean, it should not have been there, which can be modified, upgraded without requiring hardware changes. So, mostly control is through software now and without bringing entire system down. So, it is on-load, online corrections, online control, real time control, smart control, intelligent control. These are the things. You may have a card and that can bring you, it can give you access to a room, access to a library, you can go to bank, that card can be everything for you. Data acquisition system. While one controller is in action, the duplicate control is there as a hot standby, so that if there is a failure, the system won't come to a grinding halt. So, to avoid that, we will always have a backup. The backup protection idea will always be there. It will never go, come what may, whatever computers you may bring, but you will always fear, the man will always fear failure, and that is why he is always ready to face that failure, because failure is a probability. You can't the day when there will be no death, I don't think world will be worth living. That what will happen? It will be chaotic. In near future, it is expected that fiber optic system, everything is fiber optics now, wireless, these are the ADSL in your inverter connections, sorry, internet connection, it is no more dial up now in IIT. That fiber optic system would be used to generate firing signal, and the direct light fired thyristor would be employed for HVDC converters. Immense possibilities. Availability of 100 millimeter thyristors has eliminated the need of paralleling thyristors, as these can handle currents of the order of 4 kiloamps. So, this is the progress going on in power electronics area, which will affect power systems as well. Now, improvement in any area affects all the areas: materials, bio, instrumentation, control, computer, building material, anything, it will affect everybody.
So, it should be nanometers, not millimeters.
Okay, make it, or you can have multiply 10 raised to power something. As he is rightly saying, this is the era of nanotechnology, nanomaterials, everything nano. Although presently HVDC schemes operate perfectly well without the DC circuit breakers, that does not mean we should not have one.
Yes.
It is clear that the prospective extension from point to point to other DC power system configurations can gain versatility and operational flexibility with the use of circuit breakers. It will become more versatile, it will be more flexible, it will be better controllable, it can handle more power. So, there is all the way we can gain by having DC transformer and DC circuit breakers. The lack of current zero presents a difficult problem to the opening of DC circuits. This I already told you, this is the real problem, because we do not have a natural zero occurring like AC. It is by now clear that HVDC transmission is already a reliable, efficient and cost effective alternative to HVAC for many applications. I will only add that you cannot completely eliminate AC. In fact, AC will be a dominant partner in AC-DC system to my knowledge, as indeed the conventional energy sources are in energy scene. You cannot say, you cannot visualize that only solar power will supply the whole world, or only wind power will supply to the whole world. That it will always remain an optimum mix, and that mix will depend on a particular local place, local conditions and requirements. Currently, effort, R&D, lot of effort is going on in solid state technology to develop better converters, and multi-terminal DC systems will play an even greater role in the power system of the new millennium, in which we have entered 3 years back, and 21st century will definitely belong to HVDC more than HVAC than we have had in last century, 20th century. I think with this we finish the HVDC topic. Anything you want to ask, or any other point you want to know? Well, there are books on HVDC, so you can, sky is the limit. If you want to need to know more, the books are by Kimbar, by Hingorani, and our own local Indian book by Padiyar. You can read it. There are chapters given practically in all power system books. You can read those chapters. If you have any difficulty, so far whatever we have done, you can please ask. And next lecture will be on distribution systems. Hopefully we will finish that in 2 lectures, and then we will go to AGC. That will be the last topic of this semester next week.